All right, so here's the homework video for 2.4, separable differential equations. Again, I'm going to show some extra steps. You might take those steps for granted. All right, so number 2. First thing I need to do is divide both sides by y squared, multiply both sides by dx. Again, if you wrote your integral symbols here and didn't bother with this step, that'd be fine. The one thing that we do want to keep in mind, though, is I need to rewrite my y value as y to the negative second. Again, at what step that happens isn't really a big deal, but it does need to happen. These are both nice anti-power rule problems, so I add 1 to my exponent, divide by my new exponent, and then at that point I can start solving. Now, for me, I rewrote my y to the negative first as negative 1 over y, multiplied both sides by negative 1, and then used that trick of flipping both sides, right? So I flip my 1 over y, which means I flip my negative 1/2 x squared plus c. An option, though, is to keep this written as negative y to the negative first, multiply both sides by negative 1, and then rather than flip, simply raise both sides to the negative first power. It would result in the same concept. Your answer would look slightly different. Number 5, multiply both sides by y squared, multiply by dx to the right. My x values, I need a u substitution. My y values is just an anti-power rule. So I see a function in a function, I see its derivative, I see 1 square root, so I pick what's inside the square root. Take my derivative, I need to account for my coefficient, and then I find my antiderivative of something to the 1/2 power. Now, I'm able to rewrite. Notice I took my antiderivative on the left. And now again, it's a process of solving. I've got to multiply both sides by 3. So the 3 and the 9 cancel, getting me 2/3. And then I'll take my cube root, and whether you write it as a cube root or whether you write it as everything to the 1/3 power, up to you. I don't need plus or minus in this case, since it's a cube root, not a square root. All right. Number 7, again, multiply on both sides to get 4y cubed to the left, multiply on both sides to get dx to the right. Again, I see I got a nice simple anti-power rule on the left. I've got a u substitution on the right. So I pick my u value, the exponent of e, find its derivative, account for that missing coefficient, and then again, don't forget the antiderivative of e to the u is e to the u. So I rewrite my equation. I've taken my antiderivative on the left. I just did the work to get the antiderivative on the right. And so I need the 4th root. Since it's an even root, I should have put plus minus there. And again, whether you write this as an actual radical sign or you just take the time to do it to the 1/4 power, up to you. It can be pretty easy to overlook the plus or minuses. They're not the end of the world if you forget them. Technically, it's wrong, and I would have to subtract 1/2 point. But far more important is the work that got us here than the plus or minus. Number 9, divide by y cubed on both sides. I'll multiply by dx on both sides. I know that I need to rewrite my y as y to the negative 3rd so that I can use my anti-power rule. I already found my antiderivative on the right. Find my antiderivative on the left. And again, it's a process of solving. Now, whether or not you want to rewrite as I did or just leave it as y to the negative 2nd, that's up to you. But either way, before we do anything with that exponent, definitely need to multiply both sides by negative 2 so that I can cancel this fraction. Once I've done that, I've got 1 over y squared equals negative 4x squared plus c. Notice I flipped both sides, and then I took the square root of both sides. What can make this problem go a little bit more quickly is when you're at the step of y to the negative 2nd equals negative 4x squared plus c, again, simply raise this to the reciprocal power, and you would have that exact same answer. And so finally, number 12, here's one of those cases where something's not just dy dx, it's dy dt. So I moved my y's to the left, my t's to the right. On the left-hand side, I need to use u substitution, pick my u value, the function in the function, find its derivative, account for the missing coefficient, find my antiderivative for u to the 1/2, and now I'm able to find my antiderivative on the right and start solving. So I've got to multiply both sides by 3. Multiply both sides by 3. To get rid of this 3/2 power, I'm going to use the 2/3 power. I'm going to subtract 1 from both sides, and then finally take the square root. All right, hopefully that was helpful with the homework. If not, please feel free to ask questions in class. See y'all soon.